Thin layer chromatography or TLC. TLC or thin layer chromatography is a simplified version of the column chromatography, and it has several uses. First of all, this is how the TLC plates look like. They could be made from glass, from aluminum, from plastic, and they all have this white material on them, which is basically the silica gel that is spread over the glass or plastic or aluminum surface. So why do we use thin layer chromatography or TLC? You can use it to purify small amounts of compounds, and this is one of the rare uses of TLC. So if you have a small amount of a compound, and running it in the column will basically lead to losing this compound, you can use thin layer chromatography to do this. How does this happen? Let's say I have a compound and I added or loaded my compound at this spot here. With time, this spot will start moving and it will separate into two spots. Okay, so what we can do when those two spots are separated is that we can scratch the silica gel surface, which is here, and we will get a powder, a white powder, which has the compound in it. And the same thing happens here. We can scratch the surface here, and we can remove the silica gel powder, which will contain compound B, and then later on, by just dissolving those two powders, we can isolate A and B. But this is one of the rare uses of TLC. Another way for using TLC is for qualitative tests. So let's say you isolated a compound and you are not sure if your compound is pure or not, or if you are not sure how many compounds does your mixture contain, then you can use TLC. So again, we will put a spot or a certain amount of our compound that to be analyzed at this point here, and then as the this spot starts to move on, we will just check if this compound gave only one spot as it moves up. This means that our compound or our mixture is actually pure and it doesn't have impurities. Sometimes you will see that your mixture or your spot will actually separate into two, and this means that your mixture consists of two compounds or three compounds and so on. So the number of different spots tells you basically how many different compounds do you have in your mixture. Also, sometimes we use TLC to identify unknowns. So let's say I have an unknown A, and I want to know whether A is, let's say, aspirin or benzoic acid or acetaminophen or whatever. How do I do that? I will just put a spot of the unknown A here, and then I will put the known compounds here. Let's say we have aspirin here, and then we have benzoic acid here, and then we have acetaminophen here, and then let the TLC plate move on. So at some point you will notice that your compound is here. Let's say compound, the first one, or aspirin, just moved like that. Compound B is here, and the third compound is here. Based on that, I can see that my unknown compound is at the same level with this one, this spot here, which means that actually my compound A is this compound, and this is how I know that A is acetaminophen. So this is again one of the ways for using TLC. Sometimes we use it to monitor the separation in column chromatography. So if I'm using a column and I want to know whether my compounds are still getting out of the column or not, I will just take few spots of the collected solution and I put them on a TLC plate, and then check on the TLC plate of if I have a compound, my compound, or not. Sometimes we use them to choose the best solvent for column chromatography, so we can easily try different mixtures of a polar and nonpolar solvent. So let's say 5 to 1 of a polar to nonpolar and so on, until we find the best solvent that can give us the best separation. Because sometimes if you use two polar solvent, then your spots will always be very close to each other. This is bad separation. If you use a highly nonpolar solvent, then your spots may stay in here, which is again something bad. So you want to use a solvent, a mixture, which moves both the spots and separates them. Okay, so let's say if I'm using here a solvent which is two polar, for example 1 to 1 of polar to nonpolar, here I'm using 5 to 1, this is a nonpolar one, so that's why this is very slow. And here I used 3 to 1, and it looks like this mixture, which has a 3 nonpolar and 1 polar, is the best solvent to separate those two compounds. So this is again one of the uses of TLC. The principle for TLC is similar to the other ones. So we have a stationary phase which consists of silicate gel, and we have a mobile phase which is usually again a mixture of polar and nonpolar solvents. So once your compound is loaded to the TLC plate, the stationary phase will try to keep the compound by interacting with it. The mobile phase will try to push the compound to move. And this is how separation works. So how do we do TLC in plate? Usually you just have to, after bringing the TLC plate, you have to draw a line which is usually above 1.5 centimeters above the baseline here, and then you have to prepare your sample. So you take a sample of your compound, dissolve it in a solvent, and then using a capillary tube, you should be able to spot your compound here. Remember that concentrated solutions are not good, so always make sure not to dilute that much or not to concentrate that much your solution. If your spot shows here with a streak like that, this means that your compound is actually concentrated, so it's better to dilute it. If your spot is very faint and you can barely see it, this means that your solution was actually very dilute and you have to concentrate it. So after preparing the solution, you have to spot your compound on the TLC plate by using a capillary tube. You have to just put a few drops in here, and then after that after adding the drop, the separation will take place, and you have to wait until this level of the solvent moves up to about 1 centimeter away from the top of the plate, but never let the solution go up to this level, because this will ruin your experiment. And then based on that, you can, after this point, you can just detect the your spots using either UV lamps or iodine vapor or any other technique. So after running the TLC plate, one of the most important things that you should be doing is calculating the retardation factor, or the RF value. And the RF value is the ratio of the distance covered by the spot or your compound to that covered by the solvent. So you have to measure the distance from this starting point to this end point where your solvent stopped moving, and then this is distance covered by the solvent. Then you have to measure the distance from the starting point here up to this point here, and this is how you calculate the RF value, by dividing usually the small number, which is the distance covered by the spot or your compound, over the distance covered by the solvent, and your number should be always less than 1. So the RF value is a number which is always between 0 and 1. It will never be more than 1 or higher than 1. As the polarity of the compound increases, the RF value decreases. So for example, in this case here, B is the highest spot, which means that B is actually the least polar compound. whereas C is the one which moved very slow. It is the lowest spot here, and this is the most polar compound. So from the relative positions of the different spots on the TLC plate, we can know which compound is more polar and which compound is less polar by comparing the RF values. Also, it's worth to mention that using a highly polar solvent will increase RF values, so it will push all molecules to go up. Whereas using a less polar solvent will cause all these spots to move less, and they will be at a lower position compared to them if they were run using a more polar solvent.